Networks. Basic tentative syllabus I will explain. Today I'm going to do the introduction, fundamentals of data communication and transmission, second week, and third week, media types and devices, the ISO OSI 7 layer architecture, application layer. Then gradually you can understand each, each of which layers: application layer, presentation layer, session layer, and transport, network, and data link and physical. Then I explain the routing techniques and how to set up a local area network, and finally I do the revision. But this is the uh, tentative syllabus. Sometimes with if I found some new things, I will introduce that in the lecture. So what are the learning objectives of this course module? After completing this module, you will be able to understand what is a computer network and classification of the network and data communication. Also, you have to understand the media type and the devices, different types of cables, routers, switches, hubs, and differences of these devices and characteristics of these devices, and network topology and ISO OSI reference module, and TCP IP model, and comparison with ISO OSI model. Understand the layers in detail, and formation of IP addresses and routing techniques. Set up a local area network having all the features. And these are some reference books that you can refer. One is Computer Networks, and next one also Computer Networks from the Tarambanam, and also data and computer communication. I have already uploaded the soft copies, PDF copies of these books. You can download and use it. So very important. Please try to do some at each and every chapter. You can find some questions. So please do the question. Then you can have good knowledge about the computer networks. That's how you have to get the knowledge. And as an assignment criteria also I explain mid-semester exam, and here I wrote that 20, but don't worry about it. Assignments and the mid-semester exam all together you can get the 30. And today I am going to discuss these things. What is a computer network and network types, data transmission, client and server, and network components, classification of network, public network, data communication, analog and digital signals, and finally data transmission, how data is transmitted. So all of you, if someone asks from you, because you have done this one for the advanced level also, I know the advanced level syllabus. In advanced level syllabus, you can you have certain chapters about the networks. So I think when you come to this degree program, I don't want to explain from the beginning and saying what is a network. So simply, if I ask from you, actually we are in a virtual environment. If it is in the physical class, definitely I will ask someone else. But here I will explain a collection of computers and other associated devices. What are these associated devices? Printers, fax machines, or any other device capable of sending and receiving data. Even your mobile phone can connect, and interconnected by intermediate networking devices. The intermediate networking devices are hubs, routers, switches, and using some transmission media. So then there are three things to be satisfied. It must have the collection of computers and other associated devices, and interconnected by intermediate networking devices using some transmission media. So these three must be satisfied when you, if someone asks you to define a network, you have to define using these three factors. Otherwise, they may have a lacking part of the definition. The transmission media may be the copper, fiber, free space, and you know that wireless communication use the signals, radio signals likewise. Here, simply you can understand using this one the different types of networks are there, and all are connected through the communication media, using the transmission media, and also we can find some interconnected by intermediate networking devices. Devices, routers, switches, and routers. So when we consider the network types, we can find different types of everything is online nowadays. When you go to the when you come to the university and you can work, you can get some materials online. When you want to write report, you search on internet. The internet has become such a part of everyday life that we almost take it for granted. So if you want to go to a certain place, you know the address, but you know how to get there. In such a way, you can easily use the Google map and write the destination that you want to go. Then you will be given the place with guidance to get there. Like, that's why you can simply search whatever you want. If you want to search a restaurant to have your lunch today, then with your friends you are going to search what is the best restaurant, and you can get there very easily. Normally when the people use term internet, they are not referring to the physical connection of the real world. Actually, rather they tend to think it's a formless collection of connections. It is the phase the people go find to share the information. Another thing is simple internet start with the simple I, and the internet start with the capital I has a big difference. And also with the definite article, the internet, that, and just internet. The internet is the universal network that we explain, that we are used. The internet means that is a network, not is connected to the global network. Okay. Another one is when you go, whatever you are doing, you can connect. For an example, internet. The internet is not owned by an individual or group. Who owns this one? You have a certain questions to ask. Who owns internet? Who owns the internet? Is it a service providing company? Sometimes you can see you will be getting this service from your service provider, or Dialog, or Mobitel, or any other service provider. The service provider gives you the facility to connect to the internet. They are not the owners of the internet. So internet is not owned by any individual or group. The internet is a worldwide collection of interconnected networks. So you have to understand that very clearly. The internet is the worldwide connection of interconnected networks. So you know that your university has a network, that is a local area network. And also when you go to a certain office also has a network. Unless those internets are not connected to the global one, you can't share the information, you can't access the website. So you can't do it because the globally you will have to connect your individual networks to that global one. The cooperating with each other to exchange information using the common standards. So you can see the news from your tab wherever you are, whenever you want. That is because of the internet. And also phone connect to the global to share voice, text and images. If you can connect easily, you can understand the WhatsApp calls, and you can share the voice as well as images and as well as the videos with your friends and relatives. And also nowadays with this COVID pandemic situation, video conferencing as well as a Zoom meetings are frequently used. So we are also now using the Zoom lectures, and this virtual video conferencing instantly connect the people around the globe. Actually, this has several advantages. People need not to travel for a long distance for only 1 hour or 2 hours meeting. And also the resources, the fuel, the tear and wear of the vehicles or the bus fares or the any other fares and accommodation charges may not occur because each and every people is joining through the Zoom or teleconferencing, video conferencing tool, or else the Teams and the Google Meets. So those software provide the facility to meet virtually. They can share the ideas like as if they are in a conference hall. And online gaming connects the thousands of people seamlessly. I think most of you are playing the video games, connecting not only you but also not only the game friends actually all over the world. So we are playing here, someone is there in America is playing the same times with you, or else someone in the Japan or Korea can connect each other in a and do the games. That is because of this the internet. And we can find these local networks, small house network connect a few computers each other and the internet. So if you get the facility from the service provider, for an example POTV or network dialog network, you can connect your TV as well as your LAN phone and your desktop computer and laptop computer using the wireless connection. And you can small home network connects few computers and other devices to the internet. And also if you have 2 or 3 computers at your home, you can use the network printing also. Another example is SOHO network. That means small office, small office, home office network allows the computers in a home office or the remote office to connect to a corporate network or access centralized shared resources. You know that sometimes we have to use some centralized shared resources, the file servers as well as database servers and web servers, mail servers. We can use it, the centralized and shared resources, centralized as well as shared resources. ඔවුදුල්ල මල්ල ඉච්චර ගින්නේ ඔව් ප්‍රශ්නය කමෙන් හදලා දෙන්න. කමන්නේ කමන්නේ මං වාට තා චුට්ටෙන් කෝල් කරන්න බෑ හරි okay then uh, next one is the local networks. Once when we continue this one, medium or large networks, such as we can have some medium or large networks, those used by the corporations and schools can have many locations with hundreds or thousands of interconnected hosts. Hundred or thousands of interconnected hosts. And also, this is medium or large network. Actually, this is we can give another word, the local area networks. Local area networks we can have in a certain building or the company premises, or if we in our faculty premises also we can have a local area network. The hundreds of computers are connected to the network and also the net. And internet is the internet is the network of the networks. The internet is the network of the networks. That means all simple and local area and metropolitan area networks are connected together and connected together with hundreds of millions of computers worldwide. And so if a new local area network adds to the internet, you will get the continuous service without any delays or drops. So that is how we say that the scalability of the internet is very high. You can't imagine how many devices are adding a day. Sometimes each day average thousands of new devices will be added to the internet, and new local area networks, new metropolitan area networks. But the users will get the continuous circuit without delaying or without having any problem. That's why internet has the highest scalability. Scalability means increase in the size. Not only that, the mobile devices, the smartphone combines the functions of many different products together, such as the telephones, cameras, GPS receivers, media players, and touch screen of the computers. Also, tablet come to on-screen keyboard. You know the difference, and also the mobile phones also has some on-screen keyboard. So users are able to do many of things even there as if they are laptop computers, comprise emails and browsing the webs, even in your mobile phones also. And we can find some mobile devices, wearable devices. Those are actually smart watches and the smart glasses. The smart watches can connect the smartphone to provide the user with alert and message and other functions. Nowadays, you can find some watches you can connect with your mobile phone. When a call comes, you can speak by pressing the one button of the smartwatch, and you can get some up-to-date information about the weather and emails, as well as WhatsApp messages. Likewise, you can get it. Not only that, some devices provide the health information, your temperature, as well as the heart rate and pulses rates. Likewise, it will give. Then these smartwatches connect with the mobile phone, and also the wearable computer that forms the glasses, such as Google Glass. This is also available in the market. It contains the tiny screen that displays information to the where in a smaller fashion in the head-up display of the fighter flights. So likewise, you can have several devices and not and also the connect the home devices. You can connect your CCTV camera and see the inside the house or the around the house using your mobile phone and using your laptop computer. And nowadays, the household appliances such as refrigerators as well as washing machines, dishwashers, washing machines, and even the lights also can connect using your smartphone. So when you come to the, if you find some if you delay of coming home and no one is there, you using your smartphone you can switch on some lights, and if you want to switch on the heater geyser of your bathroom, you can do it before you coming there. Likewise, you can see connect the CCTV cameras and other security devices to your mobile phone, as well as you can connect your household appliances mobile to the mobile phone, connected the home devices. And even in the TV, the smart TV can connect to the internet and access content without the need of TV services provider equipment, so that you can easily connect. If you have the smart TV with Android OS, you can connect to the YouTube and see the music and see some films without connecting the service provider of the televisions. So gaming consoles also can easily connect to the network. So other connected devices are many modern cars known as smart cars can connect to the internet to access maps, audio, video content and information about the destination. And when you there are some cars I have seen that they have the iPanel connect to the internet through your mobile phone or through your any other device, and you can get the real-time information about the roads, as well as if you can search any information that you want. And radio frequency identification RFID tags can be placed in the objects, track them or monitor sensors for the connection. So all are using the networks connections. So those are the network types that we have to discuss. Another one is for the agriculture. We can use the devices to connect. Sensors can provide the temperature, humidity, wind speed. Likewise, we can control the agriculture flow conditions using some your tab with the remote devices. Curators can be automatically triggered based on the current conditions. So as well as you can program some devices to auto off when a certain conditions happen. Check the humidity and check the temperature, and then automatically triggers means without any user intervention, that can be started automatically for a certain time period, or else it can be programmed. If a certain if the humidity level comes to this level, auto on this one. And not only that, you can program with the time. Every 2 hours time, use the check the humid and send the information to the operator's laptop. Likewise, you can have some triggered events also. The medical devices such as the pacemakers, insulin pumps and hospital monitors provide users or medical professionals with direct feedback or alert with vital signs are at the specific level, so that I discuss several networks type. So starting from the beginning, then local networks, and wide area networks I explained, the mobile devices and wearable mobile devices and connected home devices and connected other devices and other connected devices. We'll see a simple video about that. This will provide actually in a Cisco Network Academy. We'll see what is this one.
Are you online? It's kind of funny because you hardly ever hear that anymore. Everyone just assumes you're online. They also assume that everything that they want to ask about or know about or learn about is also online. But what does online mean, really? My name's Patty Keefe West, and today I'm going to hopefully get you started on learning all of the complexities that go on in order for you to be online. Well, online really means that you are connected to a network, usually a network that is participating in the global internet. So basically your device, my device, any end user device, is actually connected to another group of devices, so that between me and you, there may be 40, 50, 100 different paths that my message from me to you can take. So what you see on the table in front of me are some of the devices that might be included. We have end user devices. I might be on my laptop, you might be on your cell phone, or we might be making an IP phone call. In any case, all of our communications between source and destination, you and me, are intermediary devices. These devices determine the path that your communications is going to take on its way to me and mine back to you. All of these networks are managed independently, meaning that different companies and different carriers and different providers own and manage and maintain their part of the network. So say I'm at work. When I'm at work, my work network might include 30, 40 different types of devices. And those devices then connect to the global internet. You'll notice that I drew it on the diagram as a cloud. That's because I really don't know what the network structure looks like within the internet. I only know my little piece, the part that's owned and managed by my company. Now, the internet doesn't really belong to anyone as a global entity. What the internet is it is a cooperation between all of the people that own the various networks. And these are networks that go from being very, very small, like a home network or a small office network, to a medium-sized small business network or a small enterprise, to the global carriers, like AT&T and Verizon. So those networks, the managers and the administrators of those networks agree to share a common set of rules and a common set of protocols, which is what we call rules in networking, a common set of protocols that enable communications that originate on one company's network to be able to pass through or go to destinations that are located on another network. Now, other participants in the global internet are educational institutions, governments, and corporations and companies of all various sizes. There's a lot going on between you and me, in order to enable us to be online. One of the goals of this course is to actually help you untangle some of the complexity that is involved in communications between me and you over the global internet. It's also to help you be able to build and understand how small networks work.
Okay, then once again, when you consider these networks, we can get these services. One is resource sharing. You can share the resources with your friends or someone else you want to share. Then file sharing, not only the files, but you can share the information or the documents or send the emails likewise. Then printers, databases, applications and files. The remote information access. You can access the information which is in not your computer but in a different location far away from you, sometimes several thousands of kilometers. You can access the remote information within a shorter period of time. And web and FTP, one of the good examples. Next one is user communications. You can communicate with your friends as well as make some official communication via the emails and interaction among the cooperative application programs. Another one is the distributed systems such as mobile agents. So what are the motivations of studying this one? Great saving of the time and money. When we have the network, we can save the time and money. One of the simple example is the virtual conference using the Zoom or Google Meet or Teams. We can have some video meetings. So we need not to go to the physically we need to attend. We can virtually attend and share the information. So you can you can have the meeting as if you are in physical, so that you can save the time and the money. And remote access to the worldwide information resource quickly. Not only that, if a certain incident happen wherever in the world, you can get the information within few seconds time actually, and improving the reliability and availability of the services. You can, if the network connection is stable and the power supply is stable, you can get the reliable service without any delays. Then availability, actually we will discuss later in this class why data centers are more reliable than the having the servers in the company premises. That is because they have some redundant services, they have some redundant networks, redundant power supplies. If there is happen, they will have certain backup systems to get this. So improving the communication between employees, customers and suppliers, and increasing the productivity and the revenue. You can easily understand this thing, how increase this revenue. When you consider the e-marketing websites, and before having this networking and internet, most of the companies or the located in a certain place. But with this introduction of the broadband and the web technology and with the networking, internet, and most of the people do the business, most of the companies do the business globally. So as a result of that, they could do the business in 24/7, that is throughout the day, throughout the week, without any time differences they can do. So those are the advantages. Then data transmission. Data transmission, let's see what are the data transmission actually. Types of the personal data, the following categories actually are used to classify the types of personal data. Volunteered data, this created explicitly shared by individuals such as the social network profiles, and this type of data might include the video, files, pictures, text or video. Get the example of the Facebook. Normally when you visit a certain place, you get the image and upload to the Facebook. Then others will comment on it, or nice picture, or you are going to wish for your birthdays, your other birthdays, having some images or anything. So those are the volunteered data actually. Observed data means this is captured by the recording actions individuals, such as the location of data when you are calling for. Then if you want to send the pin of your location, you can easily send a pin, and one of your friend want to come to your place, but he does not know the place, how to get that. So you can easily send the pin. Those actually they are captured by recording actions of individuals, such as the location data you are using call phones. And infrared data means this data, such as the credit stores, which based on analysis of volunteered and observed data. So if you make a transaction from your credit card or debit card, you will have to give some information. Those are called the infrared data. We'll get a good explanation of this data from one of our video. There is a certain video about that also. We'll see that.
Things we do on our cell phones. The first thing, obviously, is we talk, because that's their primary function. So we talk to people on landlines and on other cell phones, and we talk to businesses. So basically, we use one of the radios within the cell phone, and cell phones contain multiple radios, transmitters, and receivers, to do the talking. Then we also do data. And this is the kind of data that we use our data plan for. This is when we're looking up something on our cell phone when we're not near a regular Wi-Fi network. So we have the data plan network, which uses the cell phone infrastructure in order to be able to access the internet. We also have Wi-Fi. We use hotspots, and usually we also have a home wireless network. Most of us also use our cell phones as a way to get places. We use location services. Location services include our GPS, maps, places near me, and now many of us are also using our cell phones to pay for things. So we have pay services. We can take our cell phone next to the cash register or the receiver and automatically have our financial information transferred. So this is like cash registers, and payment pads. So we're going to talk a little bit now about the different kinds of networks that are used to access all of these various services.
Okay, then once again, when you come to the lesson, so then you have to understand how to transmit the data. So in your first year, first semester, under the introduction of computer systems and operating systems, you could understand the binary conversion of the data. So did you know that the computers and the networks only work with the binary digits? That's why we have to understand the binary conversions of the any of given symbols as well as letters, because the computers can only store and transmit the binary, that is zeros and ones. So each bit can have one of the possible values, that is 0 and 1, and the term bit is abbreviated of the binary digits, as I don't want to explain. So the bits. So when you convert the letter, actually, for an example, A has a certain decimal number. I remember 84 or something like that. Then if you convert that 84 to the binary, you can get 0, 1, 0, 0, 0, 0, 0, 0, 1. And if you convert the 9 to the 8-bit conversion, you can get 0, 0, 1, 1, 1, 0, 0, 1. And special characters like hash also has a certain number, decimal number, and it converts to the binary. You can get 001, 000, 0011. So this includes actually American standard characters bit translation engine, when you can enter character and see 8-bit translation. So the common method of data transmission. So when you want to send an email to one of your friends who is in a different place or the different country, the content and the addresses and the content, all of these stuff must be converted to the binary. Then will transmit through the communication media. After the data is transformed into the series of bits, it must convert it into the signals that can be sent across the network media. So the zeros and ones converted, it must be converted into the signals, electrical pulses or something. Then it can be sent across the network media to the destination. Sometimes the media is a wired connection or a fiber optic connection, or else wireless radio waves likewise. The media refers to the physical medium on which the signals are transmitted. Example of media is a copper wire. So later we can understand the fiber optic cables, the electromagnetic waves through the air, and signals consist of electrical and optical patterns that are transmitted from one connected device to the another. Here you can see simply The first one, actually, there are three common method signals transmission used in the network. One is pulses of electricity. Pulses of electricity, uh, electrical signals transmission is achieved by representing the data as the electrical pulses or on copper wire. That is, uh, basically I explained in the first semester ICS course module, zeros and ones indicate the on and off state of the electrical pulses. And optical signals, transmission is achieved by the converting the electrical signals into light pulses. The light pulses, the optical fiber optics cable use the light functions to send the transmit the data. Then wireless signals, normally the wireless signals transmission is achieved by using the infrared, microwave or radio wave through the air. So when you connect to a device with your router, the wireless connection, it will transmit infrared microwaves or radio waves to your from your device to the networking device. So next we have to understand the bandwidth and the throughput. Those are one of the most important terminologies that we have to understand. What is a bandwidth and what is a throughput? Actually, bandwidth is the capacity of the medium to carry data. So when you get the each cable or else the fiber optic or any other transmission media, radio transmission, it has a certain capacity. Capacity actually unit of bandwidth and the bits per second, how many bits that can be transmitted through that network. BPS, normally we call 1 BPS the fundamental unit of the bandwidth. And digital bandwidth measures amount of the data that can be flow from one place to another in a given time. The bandwidth is typically measured in the number of bits theoretically, but it's sent across the media in a second. So you can send it, you can measure this bandwidth from the bits as well as kbps, thousands of bits per second, that is kilobyte per seconds, and megabytes per second, as well as gigabyte per second and terabytes per seconds. Likewise, you can measure. The throughput means, like bandwidth, the throughput is measures of transfers of bit across the media over a given period of time. That is, however, due to the number of factors, the throughput does not usually match with the specified bandwidth. So within that time, how many bits can be transmitted through this line? And the throughput is the actual one. The bandwidth is the one we call the specified one. When the fabricators specify the bandwidth, but when it is used, sometimes the bandwidth that might differ, lesser number of bits will be transmitted, so that is called the throughput. So many factors influence the throughput, including the amount of data being sent and received over the connections, the amount of data, and also type of the data being transmitted, the what type of data being transmitted, and latency created by the number of network devices encountered between source and destination. So if there are only one router, sometimes you can get the throughput similar to the bandwidth, but if there are some intermediate devices connected to that one, they may have some delays, they call the latency, and the whole bandwidth cannot be used to send the data to the source to the destination. Latency refers to the amount of time, including delays of data to travel from one given point to another. So we'll see another simple video clip related to this, and we'll see we have seen that one. Actually, no need one. Go to the next.
Different types of networking components. Those components usually fall into 4 major categories. The first category is the one you're probably the most familiar with, and that's hosts. The reason I say you're most familiar with it is because hosts are usually things that interface with the human beings. So they are things like your laptop or your computer, also, your printer and various server technologies. The second major type of a network component are peripherals. Peripherals are things that do not directly attach to the network or communicate over it, and as a result don't need an individual IP address. Those devices are attached and connect through other hosts. For example, a webcam attached to your computer, or a scanner or a printer. Peripherals, though, can be shared on the network, and often are, so that, for example, if you have a printer connected to one computer, other users may be able to share it across the network. Networking devices actually direct traffic. They sometimes determine which path a particular message is going to take through the network, and they also may monitor the speed and throughput as messages travel across the media. And that brings us to the last major component, network media. Network media can be cabling, as shown in the diagram, or can be wireless. Network media provides the pathway for all of your messages to use to get from source to destination. Different types of hosts and end devices are the first things that connect to the network. We can see here we have computers and laptops, tablets and phones. So all of these devices get IP addresses in order to be able to communicate across the network. In the center area, you can see intermediary devices. Intermediary devices is another name for the networking devices that control and direct the traffic through the network. You can also see here in this part of the diagram that a firewall appliance is illustrated. Firewall appliances filter traffic so that traffic that should not be permitted is not allowed to travel across the network. And lastly, we have network media. Wireless media, most of you are probably familiar with because Wi-Fi is extremely common. LAN media is the actual cabling that connects the different networking devices, and that cabling can be copper or fiber, depending on the application. LAN media describes media that is used in a local area network. A local area network is self-contained network, usually in one location. WANs, on the other hand, represent wide area networks, and those are networks that interconnect. So in other words, for example, if you had an office in another city or another building, that may require a WAN connection in order to get from one to the other. When networkers use these icons to draw network diagrams, the diagrams themselves fall into 2 categories. The first category is a physical topology diagram. What networkers use physical diagrams for is to show how the various devices actually interconnect As you can see here on this physical topology diagram, it shows where the servers are located, the switches that they're plugged into, the routers that connect to the internet, and how the individual hosts are attached. A logical topology, on the other hand, is more concerned about how are the various areas of the network addressed and how do you reach them. Logical topologies often also show the different protocol types that are in use in various areas of the network. As you can see in this logical topology, each one of the buildings and classrooms is shown with its IP addressing. It's also showing that they are all connected via Ethernet and that the network itself connects to the internet through a filtering firewall.
Okay, then we'll understand the clients and the servers. The client and the servers role. What are the clients and the servers roles? Clients are the computer hosts, that is also a computer machine that have software installed to enable the host to request and display the information obtained from the server. And the servers also are the host computer that have software installed which enables that provide the information like email, web pages and other things. You know that web servers, file servers, email servers, you have heard these words. And when the client requests the certain web page from the web server, then the client machine must have a software installed to see the web page, that is the Explorer. Windows provide the Windows Explorer, or else whatever the software, the Chrome or any other, you must have to get the service provided by the server. And server also must have a facility to accept the request and give the reply to the client request with the relevant information. So the email server runs emails server software. Clients use the client software such as Microsoft Outlook or access email on the servers. The web servers runs web server software. Client use the browser software. That's I told you, such as Windows Internet Explorer, or access the web page on the server. And file server also store the corporate and use the files in a central location. The client device access these files with the client software such as Windows File Explorer. And peer-to-peer networks. What is this peer-to-peer network? It's a small business and home, many computer functions as servers and clients on the network. This type of network called the peer-to-peer. Then for an example, the printer is connected to the home computer to get the printouts. That is the simplest P2P network, consists of two directly connected computers using either wired or wireless network. And print server is there, then using that you can connect to the printer. File sharing, print sharing, and also the printer. Advantages of P2P, very easy to set up and less complexity than other networks, and lower cost because network devices and dedicated servers may not be required. Just you install the print server in your computer and you can easily connect, your computer can easily connect the printer to get the printouts. Can be used for simple tasks such as transferring the files in file sharing printers. There are some, even though there are some advantages, we can find some disadvantages also in P2P. No central administration, no access scarce as other networks, no scalable, and all devices may act as both client and server, which can show their performances. Actually, If it is not connected to the network, as long as the printer is not connected to the network, it will network means sharing this printer to the not only the one computer but also the others. And network printing means you can configure the printer as well as the your computer to get the printouts, and multiple computers in that location can use one printer. So the peer-to-peer thing, that is very simple but no scalable. That means scalability is one of the most important word in the computer science. Scalable means that can be added by the added the other users or the computers to get the service. And peer-to-peer applications also we can find client and server in the same machine. Client and server can be there. The P2P application allows the device to act as both client and server with the same communication. Especially the voice message, text messages use this one as shown in figure. In this model, every client is a server and every server is a client. Every client is a server and every server is a client. And also P2P applications require that each end device providers use an interface and runs a background service. In the in this figure, both client and simultaneously send and receive the messages. Then what are the role of the network as explained in the small video clips also? The computers which serves software can provide services simultaneously to one to many clients. For an example, get the file server or email server or web server. Multiple users can request the same request, but the server will provide different clients will ask the different services, the web services or else web browser, and also the client must have the software, web browser, email client and file access client. Then can we get the service from one simultaneously. Additionally, a single computer can run multiple types of server softwares. And in a home or small business, it may be necessary for one computer to act as a file server, web server and the email server, because this is the cost. To reduce the cost, get the one computer or the one server and install these many servers there, so that the server can provide the different services simultaneously for the different clients or the users. The network component also, as I explained, the network infrastructure can be divided into three. One is the end devices, such as the desktop computers, laptop computers, printers, IP phones and wireless tablets, telephone and smart TVs, and also the mobile phones. And intermediate devices such as wireless routers, LAN switches, hubs and firewalls, routers, as well as the network media that indicates the wireless media, LAN media and WAN media. So most of the time the cables, including the fiber optics or the copper line cables, and devices, intermediate devices, end devices, intermediate devices and network media is a must for a network. So end devices actually LAN, different local area networks can connect each other through the routers, and also the users can connect using the routers or the switches. So network device that people are most familiar with are called end devices or the hosts. People are more familiar with the name hosts. These devices from the interface between the users and online communication network. Users and online communication. Some example of this one is computers, workstation, laptops, as I explained you. The network printers, they are telephone and teleconferencing equipments. Security cameras also can be connected. Mobile devices such as smartphone, tablets, PDA and other things. And the wireless debit credit card readers and barcode scanners can be connected each other. So this connectivity can be the direct connectivity. That means peer-to-peer is a direct connection, and multi-point, the direct connection also we can find there are single line shared among several devices. And normally we can classify the network as local area, metropolitan area and wide area network. Local area is the smallest unit, as metropolitan area is like this local area is like the building or building or the university. The metropolitan area is larger than the local area, a certain city likewise. The wide area network is the networks of the network connecting all the network together. We can have the wide area network. So these are some examples. Connect a set of devices, relatively small graphical area to exchange information and share the resource. Multiple buildings of the lengths and single building length likewise. We can have several topologies, ring topology, bus topology, star topology likewise, we'll discuss later. And the wide area network actually provides the connectivity for lands that dispersed over the large geographic area, that is in the called the wide area network. This is a universal network. We can find the public switch telephone networks, but no more using that these telephone networks. Just I want to show you before we use the telephone lines to connect to the as the network. If the computers are located very far away, public network can use to be connect them. And what are the requirements for communications? When you want to communicate through a network to someone else, what are the basic requirements for successful communication? That is, two or more parties, send and receiver. Otherwise, you can't. If you unless you have a receiver, you can't send. And communication medium, that is a channel, and use the compatible standard, that is a protocol. The compatible standards, protocol, a set of instructions how to do that one. We'll discuss several protocols later. And for data communication occur to the communicating device must be part of the communication system and made up the combination of hardware and the software. So these three characteristics are very, very important for efficient communication. The delivery, that means the system must deliver the data to the correct destination. How it find the correct destination? Actually, the destination can be given using the IP address. So we'll discuss later. The data can be received by the intended device or user and only by the device or the user. And also the accuracy. If the data change while it is communicated, what would happen? There is no accuracy. So the system must deliver the data accurately. The data that had altered in the transmission and left uncorrected are unusable. So there are some different checks to understand and see whether the source data is transmitted to the destination. So checksum, and also the simple one of the method is the parity. You could understand in your first year ICS session parity bit check. Even parity and odd parity is the one of the primitive method, but we can have some advanced method to check the data is transmitted accuracy and timeliness. That means the system must deliver the data in timely manner. Data delivered late are useless actually. Timely deliver means delivering the data as they are transmitted in the same order they are sent and without any significant delays. So the sending data from the source and the destination data encoded, as I told you, data is converted to the bits and using some electrical pulses or the light signals or the radio signals, the data can be transmitted. The data encoded and transmitted as signals in the transmission media based on the bit pattern of the data. The sending side generates signals on the selected transmission media, whether it is the copper line or the fiber optic or the radio transmission medium, and then these signals propagates to the receiving end. So receiving side extract data from the signals and reproduce it to the original format. Once again reproduce it to the original format. So now you can understand, you can have a basic idea how data is transmitted through this communication line to the destination. So how signals are generated actually? Signals, when you see this, how signals are generated actually, the signals is generated by changing the strength or the other property of the particular form of energy with respect to time of the suitable medium. As I told you, if it is a copper line, it generates the electrical pulses, and if it is a fiber optic media, it generates as the light signals, or a wireless connection, it produces as the radio signals. Form of energy use can be electrical, light, or electromagnetic. As these three media is used: electrical, lights, or electromagnetic. The medium used can be copper, optical fiber, or the free space. The radio signals will transmit in free space. So analog to digital signals, you have heard these two words in your A-level classes. Also there are two basic types of signals. Analog signals actually called the broadband signals, right? And digital signals as baseband signals that you can see as the pulses. Also periodic signals is periodic signal if it complete patterns with a measurable time frame. You can see in one sign actually, from starting from here, this is one cycle, and once again this one cycle, and this also, the digital signals also, from starting from this place actually, this is one cycle, and once again this is one cycle, and this is another time unit. That is another one we can find, aperiodic signals. That means there is no here before you could see periodic signals produced in a certain, after a certain time period. So we can have the similar time period for each one, but here you can see A periodic signal changes the continuously without exhibiting the pattern of the cycle that respect over the time. You can see that analog signals also, even though here you can't find the similar patterns of this one. Here digital signals also. These signals in communication, actually data communication, we commonly use periodic analog signals and periodic digital signals. Periodic analog signals can be classified as a simple or composite. Simple or composite. And the simple periodic analog signals, the sine wave actually cannot be decomposed into the simpler signal. The composite periodic analog signals is composed of the multiple sine waves. So we can calculate the period of the signals. This is the radius of A, and ft is A dot sine t. A means this is the radius with sine, t means the time it's taken. And when we consider characteristics of wave, these sine waves, actually amplitude means indicates the strength of the signals at any given time. We can calculate the strength of these signals. If we want to calculate the strength of the signal in the time t1, and we can calculate using this frequency, actually f 1 upon t, t means the total time cycles per second, that is called the hertz. When the signal repeats its pattern, when the signal repeats its pattern, the frequency indicates how fast it repeats. When the signal repeats its pattern, like frequency indicate how fast it repeats. Normally we can get as hertz, the single frequency. Actually this is called the single with frequency f. This is single with frequency 2f. Understand, the frequency indicates how fast it repeats. And repeating signal, actually sine wave can completely represented by this xt. Xt is the signal amplitude at time t. A is the maximum amplitude, and f is the frequency. Psi is the shape of the signal, that is the phase is at t0 is 0. So this is actually a little bit advanced. We can calculate the frequency as well as strength of these signals using this one. Actually just I mentioned this. When you understand the complex theories of the communication, definitely you will have to study these equations and the things. And let's see, representing the signal, actually a signal frequency, that means how fast repeating the same signal. Sine wave is not useful in a data communication. We need to send the composite signal, a signal made for many simple sine waves. And according to the Fourier analysis, actually there is a calculation called the Fourier analysis. Many composite signal is a combination of simple sine waves with different frequencies, amplitude and phases. So finally you have to understand data transmission. There are two types, that is the parallel and serial. Serial can be once again divide synchronize, asynchronize and isochronize. So synchronize means simultaneous or at one. Synchronize means in a different time intervals. So that is the end